In our previous video, we saw these results here. When you integrate a power of x, you add 1 to the power to get a new power and divide by the new power, and of course you add your constant of integration. When you integrate 1 divided by x, you get ln x plus c, the constant of integration. When you integrate e to the x, you get e to the x plus c, the constant of integration. Alright. Suppose you're asked to do this. The integral of e raised to the power of, say, 3x dx. What would that be? Well, now, whatever that is, when you differentiate it, you should get e to the 3x. So, we know that when you differentiate, suppose you differentiate e to the, let's say, 5x, what will you get for that? Remember, using the chain rule, if you make u equal 5x, du by dx will be equal to 5. So dy by dx would be dy by du. In this case, y would be e to the u. So this would be e to the u. That's dy by dx is dy by du times du by dx, which is 5. Now, u, of course, is 5x, so let's change this back to 5x. Alright. So, we can put the 5 in front now and say the answer for this is 5e to the 5x. You multiply by this power. Alright, good. Now let's go back to this. You have e to the power of 3x. Now, if you differentiate something, you get e to the power of 3x. Alright? Suppose you imagine that y is equal to e to the 3x. dy by dx would be equal to what? It would be 3e to the 3x. Just like how when you differentiate e to the 5x, you get 5e to the 5x. When you differentiate e to the 3x, you get 3e to the 3x. Alright. But then, if you integrate this, what you would get is not really e to the 3x. So what you need to do now is this. When you have, if you want the derivative, when you differentiate something, you get e to the 3x. What you want to do is get rid of this 3 from in front of it, because this doesn't have a 3 in front of it, you know. So, suppose you say y is equal to 1 over 3e to the 3x. When you differentiate 1/3 e to the 3x, you get 3 times 1/3 e to the 3x. And what is 3 times 1/3? Is 1. So what you get is 3 cancel 3, so you get e to the 3x. Oh, so it seems as if, since when you integrate this, you get something, and when you differentiate that something, you get back this. That something would be 1/3 e to the 3x. Alright, plus c, of course. Now, this is suggesting that you must divide by whatever multiplies x. So, if you do this generally, the integral of e to the ax, where a is any number, dx, then what you would get is e to the ax over a. plus c, e to the ax over a, plus c. All right, so that would be our third result. The integral of e to the, well, 1, 2, our fourth result, branching from this. So if we just erase what we have here, get it out of the way, then this would indicate that when you integrate e to the ax dx, what you get is e to the ax over a plus c. Now remember, when you differentiated, you multiplied by the 3 up here, or whatever, multiply a, you multiply by. Now, when you integrate, you divide by it. You do the opposite, right? And divide by the a. Then you add your constant of integration. We'll continue looking at integration in the next video.